The purpose of today's lesson is to talk about the slope. We learned in the previous sections that the constant rate of change. Well, that's also called the slope of a line. Here's the definition. The slope of a line describes how steep it is. It describes the change in y values compared to the change in the x values. So what you're going to see quite often is the change can be written with a triangle. This represents change, the change in the y over the change in the x. You'll see that a lot in physics. And m represents the slope. The following investigation will examine how slope is measured. Okay, on properly built staircases, all of the stairs have the same measurements. The important measurements on a stair are called the rise and the run. When building a staircase, these measurements are chosen carefully to prevent the stairs from being too steep and to get where you need to go. There's a code nowadays. You have to have the stairs at a certain steepness. One step from 3 different staircases has been given below. Staircase 1, 5 inches, 5 inches. Staircase 2, 3 inches, 8 inches. Staircase 3, 6 inches, 4 inches. The vertical measurement is the rise. So each one of these is rise because you're going up. Here is your rise. Okay? And then the run is the horizontal measurement. Run, run, and run. And the slope is always considered the rise over the run. Okay, state the rise and run for each staircase. Well, this first staircase is 5, and the run is 5. Okay? The second staircase is the rise is 3, and the run is 8. Next one, rise is 6, run is 4. Using the rise and run for each step, graph the height a person will be at after each step for the first 5 steps. Do this for each staircase. Okay? So let's start with the first one. Well, staircase number 1, I'm going to do in red. And that one is 5 over 5, up 5, rise 5, run 5. Rise 5, run 5. Up and over, up 5, and over. So that's what that's going to look like. The next one, number 2, let's do in blue. And that one is rise 3 over 8. 5, 6, 7, 8. Up 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Here, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay. And lastly, we'll make this one green, and that's 3, and that one was 6 fourths. I wish I would have written the others. Okay, 6 and 4, up 6, 1, 2, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Oh gosh, that's 12. That'd be 18 here. 1, 2, 3, 4. Okay, so now what we've done is we've graphed the rise over the run. The next question is, which staircase is the steepest? That's on the next page. Which staircase is the steepest? Well, which one's going up faster than the others? And that would have to be the green one, which is staircase. This would be number 3. Just like staircases, the measurement of the steepness of a line is also very important information. On the graph on the previous page, draw a connecting line from the origin through the tip of each stair. Okay, so let's go back, and we'll start with the green because I have the green up. So we're starting at 0, 0, and we're going to go all the way up through. I'm going to try to hit these. Okay, that's that one. Then blue would be next. And it disappeared. If that circle comes on, then that means it's going to disappear. There's blue. Let's try green again. Have to be kind of quick with it. You can't stay in one spot. There we go. And red. That's line number 1. That's 5 over 5. Okay. So we've completed that task. And then it says, find the slope of each line representing a staircase using the rise over run, or y over x, and by simplifying this fraction. Okay, so staircase 1 was 5 over 5. And we have to simplify that, which would give us a 1. Staircase 2, that was in blue, and that was 3 over 8. Nothing to simplify. And the last one was 6 over 4, which can be simplified to be 3/2. If you didn't have the graph to look at, only ratios you just calculated, how would you know which staircase would be the steepest? How would we know? Well, let's compare. We've got a number 1, we've got a 3/8, and we've got a 3/2. And obviously we know this is the steepest. So obviously, the greater the ratio, so the greater the ratio, the steeper. Or the greater the fraction, or the number. Look at that, was the biggest number of all 3 of these. So that would be the steepest. So the higher or the greater the ratio, the steepest. Calculate the slope for climbing 1, 2, and 3 steps on each of the staircases. Okay, I'll start with 1. 1 step, the rise is 5. The total run is 5, and the slope is 5 over 5. Okay, if you go 2 steps, your total rise would be 10. Because think, you up 5 over 5, up 5 over 5. So now we're trying to figure out how high, and we would go over 10. The ratio is 10 over 10. 3 steps would be 15, 15, and would be 15 over 15. Okay, I want you to complete staircase 2 and staircase 3. Oh, sorry. Oh, that's my puppy. He's barking at the neighbor's dog. Sorry about that. Alright, complete staircase 2 and 3. Okay, I'm not going to fill this in. I'm going to have you fill that in. But I want you to notice the slope. Look at the slope for each one of these. It's 3/8, 3/8, and 3/8. If we jumped back here, 5/5 is 1, 10/10 is 1, 15/15 is 1. These slopes are all the same. And it should be the same with this once you fill this in. So what can we deduce from this? What deduction can we make? Does the slope of the staircase change as you climb each step? Does it? No. No. The slope is consistently the same. The slope is consistently the same. No matter what step you go from what step. The ratios are all the same. Ratios are all equal. 3/8, 3/8, 3/8 for staircase 2, 1, 1, and 1 for staircase 1, and then you're going to figure out number 3. This next part, number 8, there's going to be a worksheet to go with that, so you can just ignore that. And tomorrow we'll do an activity with staircases. So this concludes our lesson on slope.